Hello, this is Rakesh Rao from DesignSense Software Technologies, Bangalore. In this GeoTools video, I will show you how you can create some nice topology around your polygon objects. Now what you see in this drawing is a set of lines which comprise of different polygons representing some land parcels. But if you select them, you can see that they are all disjointed segments. It has not yet been built into a polygon topology, which is often required in mapping and GIS purposes. So we go here to GeoTools and under the build tools, so there is a command here called create closed polylines from a mass of networked polylines. You can run this command on the command line also by typing gt_ccpoly. Now when you start this command, you get this dialog box which allows you to set a lot of parameters. The first one is what do you want to place at the boundary centroid, points or blocks. So typically you can choose points, or if you have blocks you can select a block name and use that. So I'm going to select points. The next important part is the scan method. Now there are two options here, automatic and selected points. Now if you see this data here, I don't have any points which have been provided or drawn earlier, but in some cases you may have points which are already available and you may want to create polygons around that point. So in that case you can use the points option, but here I'm going to use the automatic option. The automatic option allows you to specify a rectangular frame, and then based on a scan size of the window, it will scan throughout that area and automatically determine which are the points where the polygon is to be created. So it's important to set the scan window size correctly. Setting it too small will result in the program running slower. Setting it too high will result in the program not being accurate because it may not be able to find the data that it needs. So you need to make an assessment as to what is the most optimum size of the scan window. Now this can be done by looking at your drawing. Now if you look at this drawing here, you can see that this is probably the smallest size of the polygon. The distance between these two lines here is probably the smallest size, and therefore it makes sense for me to set a scan window which is either of this size or maybe something around that size. Now you can check what that size is by clicking on show size, and I'm just going to select 2 points here. So if you select those 2 points, now you come to know that that distance is 4.69. so to be on the safe side, I will just set it as 4. But remember that setting it lower and lower means your program will take longer and longer time. Once that is done, you need to set the layer for your polygon boundary. So I'm going to choose polygon boundary as my closed built topology layer. Then you can filter manually from selected layers only those entities which go into the computation. So in this case, let me just select this poly as a layer. Now the poly is the layer in which these individual lines are there. If you don't know that, you can just pick the point here. Now I'll say select objects, and I'm going to select all the objects that I want to be considered for processing. Now once that is done, I'm just going to press OK. Now again it's asking me pick first corner. So this is the first corner of the scan. So I now need to pick 2 corners which totally contain my area. Now this is where it's going to take some time, and like I said, setting your scan window smaller will increase the time significantly. So you need to do some tests and find out what is the best size required for the best trade-off between size, quality and the time it takes to complete the operations. So let us wait now. You can see already that the polygons are being built, so it's not all that slow after all, but this is a small data sample, so it's doing it at this speed. And I recommend that if you have large data samples with you, you can process them in small parts like this. Split your big data into small parts, maybe split a big polygon into 4 or 5 different smaller parts, and then you'll be able to process it successfully, easily, and with lesser errors. Okay, so it is done now. So you can see that all the polygons have been created and the topology has been built correctly. There is a centroidal mark as well as there is the closed polygon boundary. So this is how the tool works to create topologically correct closed polygons from a mass of data which are different. You can get this command on the command line also, and you can get it from the ribbon as well. If you come here to the GeoTools command on the ribbon, and if you go to the build options, you can find these options here. This command works identically in AutoCAD as well as in DWG CAD. Now there is another way in which you can use the CC Poly command. So under the build tools, we come back here to the same command, create closed polylines from a mass of networked polylines. Earlier we showed you the automatic option, and now I'm going to show you the at selected points options. So when you're using at selected points options, you need to select points and the polygons will be built around that point. Now you can see that in this sample drawing I have polygon edges and then I have points placed here. Now from these polygon edges I'm going to create the closed topology polylines. So select layer to place the closed boundaries, so polygon boundary layer. Select layer for the polygons, so this is the one. Select objects, I'm going to select all of this, and now at selected points I say OK. So select entities. Now I need to select all these points, so I think I can just select all of it because it will filter the linear elements out. So you can see that it has created the closed polygons now. If I come here to closed polygon boundary, so you can see that the closed boundaries have been created here. So this is another way in which the gt_cc poly command can work. So we showed you two methods. One is automatic scanning and the second method is when you already have the points. So in both cases the output is very much similar. The slight difference is that when you have the points, only the polygon outline is created, and when you do the scanning, both polygon outline as well as the point is created. So these are the two ways in which the gt_cc poly command can work. Thank you for watching this video, and do let me know if you have any questions.